Thanks for inviting me to speak at workshop in analytical sociology at lovely Venice this year. And the subject of my presentation is methods of transformation research, and the subtitle is the case of sustainable transportation. I want to discuss the contribution of social sciences to transformation research, and I'll start with some very general remarks. What is societal transformation? And from a point of view of a sociologist, transformation starts with a system at a point of time T1, which is the present. And imagine a system in the area of industry or energy or agriculture or health system or the education system or the transportation system, any system of that kind. Maybe there's poor performance and we are not very satisfied with this system. And maybe there's also some external pressure, for example, for cases of climate change, that wants us to change this system and to get to a better future system at a point of time T2, which is sustainable, of course, which is economically efficient, which is safe and reliable, and which is as well socially fair. So how to get from point T1 to point of time T2. So, of course, this needs some kind of transformation, of system transformation, and politics, of course, is in charge to promote and foster this process. But my question or my issue today is what could be the contribution of social sciences to analyze the current system state, to envision a future system, and to make suggestions for the transformation process. And if we look at our discipline, social science, we have a lot of data. We have a lot of data, behavioral data about the daily behavior of people. For example, in the case of transportation, why some people take the bus or the train, public transport, and other people take the car. So we have a lot of evidence how the state of the system, the supply with modes of transport, for example, the state of the system influences the behavior of the people, and how the behavior of the people, vice versa, influences the dynamics of the system. So from my point of view, sociologists typically try to explain and understand individual decisions. And by doing this, we try to explain system dynamics, of course, of social systems. Additionally, we typically try to explore options for intervention, maybe political interventions into the system, and we try to develop pathways or scenarios of transformation. And the most difficult part is to predict the future system state. Is it better or even worse? And so the question arises, are we able to predict the future? And the simple answer is no, but there's a more complicated answer. And to give this answer, I would like to look at other disciplines. How do other disciplines perform this difficult task of prediction? Let's have a look at weather forecast that predicts the weather of the next day, or economic forecast, the economic performance of next year, or even climate research predicting the development of global warming over some or several decades. How do they do this? How do they manage to perform this task? The first issue, they have a large amount of data. But they do not only have data, they also have a model of the system, of the economic system, of the climate system, of the weather system. And a system model typically consists of two ingredients. The first is the events, how the events at the micro level, local events, local weather events, local economic behavior and so on, relates to the dynamics of the system at the macro level. You need these two levels, and especially the interplay between these two levels. That is the key element of a system model in those disciplines. So, and to develop this system model, you need some theory, of course. But there's a long way to prediction, how to cover this way from system model, from data to prediction. And I think in the midst of this process is scenario. You have to build scenarios. Scenarios are a combination of models and data. You have a general model how a system performs, and you have specific data about the, let's say, weather development, the climate development over the last couple of weeks, and then you put it together and create a scenario how the specific system has performed and maybe will perform in future. So you put together theory, models and data into a scenario. And then you need some computational power of typically to verify, to check, to examine the assumptions deriving from this scenario. This is a very complicated process with many feedback loops. You put in again your results into the scenarios, adjust the parameters and so on and so on. And finally maybe you reach a prediction or are able to make predictions. This is the case in other disciplines. So my question arises, and the result, of course, the result of this kind of making science is, for example, the climate, the prediction of climate change until 2100, which is a very long time, but you see the amount of uncertainty, of course, here. So my question is, can we do the same as well? Can we, in social sciences, make predictions about future states of social systems? Can we apply this model, this procedure to our discipline? And my answer is yes, we can and we should apply it. First step, or no, these are the fields. For example, we could apply it to predict future mobility behavior, to predict opinion dynamics, for example, in the case of fake news, or to predict the behavior of people in the pandemics, and to create scenarios how to change this behavior. So the first step should be we should apply some theory. We have very good theory. I won't go into detail today. Of course, we have a very powerful method of surveys and other instruments of empirical social research to develop data. And we have, of course, some methods and tools, for example, expert workshops or lay people workshops to generate scenarios. And we have a lot of powerful computational tools in the computational social sciences, in the statistics and other disciplines to make the computation and the verification of the hypothesis deriving from the scenario. So we could make predictions as well. I would now come to the project InnaMoRuhr, where we apply this approach. I go back once. We apply this approach in a recent project which is called InnaMoRuhr. The English translation of the title is a long title, is Concept of an Integrated Sustainable Mobility at the University Alliance Ruhr. We are several institutes working together to make mobility of people of the universities more sustainable. And the first step has been a survey where we gather data about the mobility behavior, but also about future mobility needs and wishes. Now we are in midst of creating scenarios by means of scenario workshops, but also by simulation experiments, computer experiments. And in the next year, we want to establish a real-world lab with field tests where we will test new technologies such as e-mobility, but also new services such as on-demand shuttles or something like that. So the main question, or the key question of this project, are we able to change mobility patterns of members of the three Ruhr universities? And as you see, this is the strategy is generating data, producing scenarios, making experiments in the real world, but also in the computer lab, and then try to predict possible or explore possible futures. We are a team of 3 universities, Dortmund, Bochum, Duisburg, 7 teams working together, and is funded by the Ministry of Transportation of North Rhine-Westphalia. And I will give you some first results of the survey. This is the trip, these are the trip change of about 8,000 people, starting in the morning at home, going to university and back home. And you see some blue, dark blue, starting at home directly to the universities. Others go by foot to the train station and then take the train to the university. Some have to switch once or twice to get to universities. And on the way back, most people go home directly, but others go to shopping or to leisure activities. So this is a kind of visualization of a large number of trip chains. Very important for us is to have a look at the mobility patterns, which is the situation before Corona, before COVID-19. And you see the three groups: the academic staff, the administrative staff, and the students in green. And here is public transport, here is individual transport, which is bicycle or car, and here is mix, which means intermodal transport, switching between different modes of transport. And you can easily see that students use public transport and intermodal transport, and the administrative staff mostly takes individual modes of transport. And here we have a situation before COVID, where you see that many people took public transport, about a quarter the car, and some bicycle and walk. And this changed dramatically, as all of you know, after Corona, after the COVID-19 pandemic. There's the large increase at the car and walking mode, and a huge decrease at public transport. But we also asked, what would you like which mode would you like to take in future? And this is remarkable, because numbers of the combustion car dropped down dramatically, and numbers for sustainable engines, drives, go up here, but the number is almost the same. In future, about 1/4 of the people would like to travel by car, but more sustainable. Here we have the bicycle. There's a huge increase, and you see people want to travel individually and flexible, whereas the public transport gains again some percentages, but it's not the former level. It's much lower than the former level. And you see here walking again drops down, but there's a dramatic loss for the public transport and the desire to travel individually and flexibly and sustainable. We ask people for options of behavioral change. For example, going by bicycle to the train station and then take the train to the university, and about 3/4 said, yes, we would like to do that. Taking the shuttle, the autonomous shuttle or something like that to the train station, that was rather half of the people, and carpooling was a little less than half of the people. And this differs a little bit between the groups, where you see the administrative staff, which is slightly older than the average, is more skeptical, and the other are more positive. Very important for us is to understand the decision making of the actors, to understand the individual preferences, which shapes their mobility behavior and which also shapes their ability or their willingness to react to, let's say, political incentives. So we made a cluster analysis, and the result were 5 actor groups. I will not comment every detail. You see here the characteristics. We asked, do you want to travel fast or cheap or eco-friendly or comfortable, and so on. And let's have a look at this number 4, which is the comfort-oriented actor type. He doesn't care about, she or he doesn't care about costs or environment, but comfort and safety are the most prominent features. And the ecological people here, they don't care about comfort and safety, but the most prominent, the most important feature is eco-friendly and cheap. So we have actor types. We need to understand the decision making and the ability to react to various incentives. For example, the comfort-oriented will not react to financial incentives because he or she is not interested in the factor costs. Here you see again another chart differentiating these 5 types to the 3 groups: academic, administrative staff, and students. And you see in the administrative staff we have a lot of people which are comfort-oriented and typically take the car. So where are we now? We are now in midst of the project. We have a lot of data, a large amount of data, and now we are going to start scenario workshops, and in the next year, of course, the real world lab. And so let me rephrase our work in terms of this concept here. We have a lot of data, as I showed to you, about actor types, about mobility needs, about policy options, and so on and so on. We have a system model. We developed it before the project, but it works and it is adjusted. But the main features of this system model are the rules of individual decision making, the rules of interaction, the mechanisms of emergence, and the options of intervention. These are the main features of this system model. We have a simulation engine running, which is our simulation engine SimCo I presented in Venice 2 years ago. We are now switching to MatSim because it's the most prominent and most used simulation engine, but we want to incorporate some components of SimCo into MatSim, but we will use MatSim in future. So we have many ingredients we need to accomplish this class of predicting future mobility. What we are doing now, we are conducting scenario workshops, not with experts, but with lay people. So maybe in some future we will be able to give some predictions about sustainable mobility, pathways to sustainable mobility, based on our experiences with experiments in the real world and experiments in the computer lab. So thanks for your attention, and thanks to the InnaMoRuhr team. Thank you.